Alright guys, welcome to my channel. So for today's video, I'm going to continue my tutorial on KiCAD as the previous video. So without further ado, let's get started. Um, so this is the schematic we've created based on yesterday's or previous videos tutorial. It's kind of like messy. There are so many problems here. So like today's video, I'm going to show you mainly four aspects of how to make this schematic and PCB board better. Okay, the first thing is how to add a battery on the schematic. And the second is how to use labels to denote wire types, for example, the ground ones and VCCs. And then I will show you how to add those resistors for silkscreen printing. And finally, I will arrange this layout of PCB board better to make it finished. All right, so let's get started. So I would like to start with the battery. So on KiCAD schematic, you can add batteries with this toolbar or like with this tool on the toolbar, like add a power symbol, or just press P for power. Okay. All right, it is showing up on my other screen. I need to drag it here. Where is it? No, this is weird. Okay, there we go. So what we want to do is actually to add a power. So let's say, is there a power symbol here? Oh, actually not. The reason is that powers here are actually the real devices, not these representations, because like these things are for abstractive meanings. So what we need to do is still press A to add a real thing instead of a power symbol. And yeah, here it is, battery management. Does this stand for battery? Actually not. Okay, let's search for battery here. Okay, so here, like there's a thing named battery and there's another thing named battery cell. So I would say like this one named battery cell looks better because like there's only one battery symbol there. Like I don't get it, like why there are two for this like multi-cell battery, right? Like in most cases, like there is only a single cell for us. So let's select it and add it here. So now as we can see, like we've added the battery cell here. Later we need to assign it with footprints, of course. Otherwise, the PCB board cannot recognize it. So the next step for us is to connect this thing to our circuit, right? So the simplest way of doing this is, of course, to add it to the VCC wire here, because this is the power or battery, the power source for driving all these kind of devices, and mainly for the MCU, because as we can see here, the electricity, like it flows from the battery, it should be flowing from the battery, then to the MCU's 5V pin here, and it will start this MCU. And its 3V3 output pin can also provide regulated voltage for any other devices. So we've actually connected the potentiometer and the button here as well, right? And for other VCCs here, like this SSD 1306 OLED screen, it is also being powered by this 3V3 pin. So actually, right, there's no device that is directly powered from this battery. So what we can do is relatively easy. I would like to connect it like this. Get rid of this VCC notation. Maybe we don't need this thing as well. And what we will do is just to connect it here. All right. And of course, the anecdote or um, the negative side of the battery shall be connected to the ground. So, okay, I selected the wrong thing here. All right, here we go. This is just pretty simple, right? And now what we shall do is to assign the battery with a footprint. Go here, okay, find this battery cell. So if we try to find battery things for here, there's a tab for it actually here. But if you look at it, you will see that this is not exactly what you want for a battery. Because like this is not ideal. So what I mean is like this. Assuming that you've got a battery box like this, let me see if you can see this. Yeah. So if you've got a battery box like this, there will be like two wires wiring out from this box, and it should be connected to your PCB board, right? Not directly to your MCU. So like there should be two pins on or two pads on the PCB board for you to solder those wires on it. So this is pretty simple. And so what we want to do is actually find that kind of connectors or battery pads. But as we can see, like here, like all these things are pretty much for AAA or like real batteries, but not boxes. And on the other hand, using these kind of boxes to connect the battery with the PCB board is actually easier because what you can do is to just select a connector like this, connector JST. And as we know, we need two pads or pins for a battery box's two wires to be connected. So we can just type in y multiply 0, 2. And yeah, here are the connectors we want. And as we can see, even though this feels like a connector or a connector of, for example, like you can use LiPo or whatever connector or headers to connect this thing with, you can still like connect wires directly to it because this thing is nothing much but two pads or two through holes on PCB board. And since we've got wires here to be soldered, I would say like we can use like wider gaps between those two pins or pads. So I would say I would not use this 2.5 millimeter one rather than this thing. Let's try this NV. Yeah, NV 1 multiplied by 2, 5 millimeter vertical. So this feels like a pretty good connector for batteries because like we can directly solder the wires on it. So I'll double click this and okay. And here we go. And yes, I think this is pretty good. I'll press Ctrl and S to save it in case I lost anything. And I can then go back to my PCB editor, update my PCB, 0 warnings, 0 errors, pretty good. And you can see like this connector for battery is being added. Okay. So what I want to do right now is to rearrange this PCB board because as you can see here, we've got a problem at the end of last video, which is that the button here, those pins to be connected to the microcontroller is on the other side of it and we cannot reach it because like it's pretty obvious that these wires here or these tracks here are blocking it from being connected. So what we should do is actually to rearrange this layout a little bit. So I would like to just erase all the tracks I've added yesterday. Perhaps all of them, because I really don't like them actually. If you are doing it at the first time, you really need to think carefully about the layout of these things, right? And would also, I would also I'm just gonna remove all the tracks here for the OLED screen here as well, because as we know that these pins on the microcontroller are gonna be connected with the button here. We would like to move it a little bit downward here and move the OLED screen up to the top of the PCB board. So like we might get a better layout for routing. Okay, so I'm just like literally deleting every single track that I've created yesterday. Yes. So you can skip this part, of course, if you are watching this video. Okay, I'm gonna just, okay, this is so much easier. Okay, I'll try keep this bottom part untouched if possible. Okay, and then I'm gonna move the PCB board here and the screen a bit upward. Okay. So this is a little bit stacked, but I think it's okay. All right. This looks better. I'm gonna increase the granularity I can use. Right. And yes, I think this should be better. We can connect those four pads to the pads here from here, and those pins can be connected directly from here. Yes, and on the other hand, we can connect this one. Okay, this one is a little bit tricky, but I think this is doable, right? Or is it? Let's see. Okay. Okay. So the most difficult part is about the MCU, because like it has too many pins on it, and it will be like pretty difficult to manage it, like if you are doing this the first time. And so do I. Oh, I really hate there are tiny bits of these tracks being left there. Okay, so let's do this all over again. But first, what I want to do before rearranging all of these layouts here is to do this schematic better with better labels. So as you can see from my screenshot of my finished PCB design here, there are VCC labels besides GND labels here as well. So the reason is that with these VCC labels being defined, we can use them to set the net class of different tracks, and PCB editor can automatically select the desired width and other characteristics for our tracks to be created. Okay, so what I want to do is to give this give these VCC some names or labels. So as I was like keeping saying labels, 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 you might can guess that the short key for creating labels is L. Okay, so hold on a second. Press L, and here it is, a label window here. And we'll say VCC, press OK, and you can see that there's a square here. You need to put this square right on the wire you want to create the label for. So you cannot put it anywhere else. Like here, you must put it on the top of a green wire here. Since this thing is actually the VCC or the power coming through after the switch being controlled, so we are gonna name this thing as VCC. And afterwards, if you click this wire and select it, you can see like there's a default VCC named here. So that means like this wire and all these wires being connected together are named as VCC. This is pretty cool. I like it. And I also want to give the battery cell a little bit a label as well, maybe named BAT. Okay, so here is named BAT, and you don't need to name this ground thing because you are connecting it with the ground label here, so it is already being labeled as ground. Okay, and what's next is that I would like also to label this 3v3 wire here because it is also being used for powering, but it is not for signal processing but powering. So L3v3 here, and then we can see all these wires are being named as 3v3. All right, I'll click save and go back to my PCB editor. And what I'm gonna do next is to edit the net class preferences here. And as we can see, we've got VCC and GND being defined here. I'm also gonna add 3v3 and say power and BAT power. So when we are routing or creating tracks for these kind of wires, it will use the preference of power name class here, which means like its minimum track width will be 0.5 millimeter. That's okay. And then let's try it. Maybe from here, there's a 3v3 pin here, right? You can definitely start from this one. Is that it? Not that sure. Oh, guess what? I forgot to do a thing, which is to update the PCB. Okay, there we go. Here's the 3v3. Is this thicker? No, it's not. It is not. So why is that happening? It's because it might start with a slash. Let's try again. GND 3v3. There we go. Now they're thicker. Okay. So how about we starting from this easier and like more open space one here. So let's do this. Right. It is not that ideal. I would like to increase or decrease the granularity a little bit. So like, okay, I like this wiring. Okay. So this one is meant for the other side. Oh, okay. I really don't want to do this because it will block all the potential spaces here for the motor to be connected to the pins here. So what I want to do is probably, routing from the very edge of it to here. Okay, I think this is okay. And for this one, I should have left enough room for it. Oh, guess what? What a pity. This is not good. I definitely don't like this. As long as this is doable, I would like to do it because this pin is not being used. So like it doesn't matter if we just like mess it around and totally block it from anywhere else. Okay, and we definitely need to place this VCC pin in a good manner. So we can have this R here to help us. Okay. So if there are wires coming from here, where is the best place for the R? Maybe just here. I'm not really sure like whether this is doable. I just need to try it. I'll rotate it a bit. I really don't like this style of routing because like they're being too close. You know, like you are going to hand solder these things all together in the last step. So I highly not recommend putting all these things so tight, right? Like don't like make this more difficult, add the difficulty for yourself. Like it is not good to do so. Okay. So if we do this, this part will be totally blocked. If we do this, it's the same. Okay. Okay, shall I try the other side? Yeah, I'm feeling like I should put the MCU on the other side of the board. So I might get more open spaces here. Let's see if it is possible to wire it in the current setting. Okay, it is not. Okay, so if you noticed, I think yes, perhaps. So if you are noticing something the same as me, don't panic. Like this happens a lot, especially when you are just like really just getting started. Okay. So I need to delete these wires all over again. All right. Yeah, because like this time we can definitely connecting this pretty easily, I would say. Just these wires are so, how to say, like if this pin goes to here rather than here, this would be a really good shape for us. So what I would do is to switch the connection between 3 and 4 here in the schematic. So let's say I'll connect 3 to 4 and 4 to 3. There we go. Save, go here, update PCB, and as you can see right now, we can definitely do this in a way much easier way. And here we go. This is definitely better. And this is definitely better. Since we rotated it, we can get this done without any difficulties, because on the other side, this pin is on the other side of this one, so like they have a cross thing happening there. But like if after moving this one here and rotated it with 180 degrees, we got a pretty good shape of it. All right, I like it. And then we can try connecting the VCC to the switch, G and D to the power input, and battery to the other side of the switch. Good. And 3v3 for this connection. I would definitely rotate it a little bit to make sure that it goes here to here without any difficulties. And this one is not being used. This one is for R2. So, okay, rotate it. So as you can see right now, like there's really an open space happening here. This is definitely not that ideal, but acceptable. I'll move this one to here so that they are being connected in a better shape. Okay, or this one. Okay, I can connect this one. There we go. Yeah. Oh, this is really in a good shape right now. I like this so much. I mean, I do like it. How about I put it here, and the other part, can I go a little bit further? Because I really don't like this, but like it's safe, like as long as there's a gap in between, so like you won't solder it in a really difficult way. But you know, as long as possible, I would give there a larger gap for connection. All right, and here and here. Okay, so maybe let's no, it's fine. Just do this and this. All right. Shouldn't be too difficult to solder actually. And let's see what else. Oh, this is definitely not ideal, right? Avoid these kind of angles, like. Because that thing is totally unnecessary, right? And for this one, just go straight here. For this one, okay, this is a little bit weird, roundabout, but it's fine. It's really kind of fine to have that. Okay, so here's the problem, maybe. Here's the problem. So these buttons, like inside it, like they are internally connected actually. So you don't really need to like connect it like this. But I would rather do this because I want to make sure like all those thin blue wires here are disappeared. Okay. I need to connect that one here, maybe like this. So I've got the only thing which is not that easy to be connected is this 3v3 to here. Wow. Okay, so here's the problem actually. So finally we're running into some problems, and if we connect it from here, no, okay. All right. Is there any better ways of doing so? Why is it creating such a bad shape of it? I mean, okay. So the problem is like, actually we can just give it some kind of more space of connecting that part of it. So let's say, hey, why don't just do this? And, therefore we can avoid this kind of angles, definitely. Okay, and then we can, well, this is nice. Okay, and this routing, this routing is so weird, and this ground routing is also weird. Are there better ways of doing so? Here we go. We can just connect it like this. Okay, problem solved here. For this one, so for here it's definitely not doable. So apparently we can just like let it zigzag like this and goes here. This is definitely not the best choice of doing so, but it's working. And let me see if there are any ways of making this simpler. So what kind of node is this? 3v3. So 3v3 shall be connected from here and yeah, directly to here. And had we switched the position between the button and the potentiometer, it could be better layout. There could be a better layout, But I'm just not gonna do that, and I think this is definitely good enough to work. So let's use inspect design rules checker, and there will be a window showing up, and you will see run DRC. Okay, there are 0 errors, which means fine. Like you can definitely print this board and solder all the parts of it on it without running into any, well, like circuit designing issues. Okay, but like there are 8 warnings as well here, and saying something like silkscreen clipped by board edge. So this thing means that for those silkscreen printings, they might be cut off or being like covered by some other traces on it. So like you cannot read it after them being printed. I'll cover these things later in the tutorial. And as for now, I would say this is a pretty okay, or maybe not that okay. So here, like this is definitely something we need to avoid, just like this. Yeah, okay, here we go. Right, looks okay for me. right. Yeah, and here we go. Let's click save, and so I'm gonna tell you another thing. And next step is for silk screening, which is what I mentioned earlier. So as we see here, like there are resistors on your circuit, but the problem is like their resistance values are not being filled. Okay, so that's what I want to do next. So for each component on your circuit, you can edit their characteristics on KiCAD's schematic design or editor. Okay, so as I'm saying that you can edit it, so you might guess that the shortcut for it is E. All right, so click this component, press E, there will be a simple properties thing showing up. So now for here, like the values here, it is using R as a placeholder here. We want to fill in it with the real and specific value for this resistor. Okay, and as you can see here, what is R being used for? Okay, so I'm asking a question here. So what is R being used for? So you can pause this video for 3 seconds and try to find that answer by yourself. Okay, 3, 2, 1. Okay, as you can see that R is connected in serial with this D1 LED. So it is here to protect the current flowing through the LED. Or I mean like protecting the LED from being destroyed from a large current. Okay, so how to calculate the value of R? Okay, this is a question, and I bet I've covered this in the lab tutorial several weeks ago. So let's assume that we are going to use this kind of LEDs here. I'm going to switch this to the thing here, go to data sheets, and yeah, assume this is your LED to be used, and you can find that it's typical or ordering at IF is here like 20 milliamp. So you want the current flowing through this LED to be 20 milliamp, okay? And there are maximum ratings here, and the maximum rating means like you cannot let those values exceed the values being printed here, right? Like if you are letting, for example, current with 3 milliamp flowing through the LED, it might be destroyed. And for LEDs, what we care about is actually this forward current and forward voltage graph or figure. So it plots if this kind of voltage is provided between the two pins of the LED, what is the current value flowing through it? Okay, and as you can see, this is not a straight line or linear line. That's because LEDs they don't follow the Ohm's rules. Okay, if they follow Ohm's rules, these things shall be linear, right? Like resistors. So if we want its current forward current to be 20 milliamp, I will say, okay, here means 10, and here means 100, and here means 50. So 10, 20, let's see. Okay, here's the node. Okay, so it means that its forward voltage shall be 2 volts. All right. Okay, so after knowing that the correlation between the forward current and forward voltage of an LED, you can then use Kirchhoff's law to calculate your protecting resistor's resistance. All right, so let me show you how to do this. So first, you need to know that what's your battery's output voltage. Like if you are using a LiPo battery, it might be 3.7 volts. And if you are using AAA batteries, it could be just 3 volts or less. Okay, so assuming that you are using a LiPo battery here, so it means like your power output is 3.7 volts, and it is going all the way across here on both sides of both R1 and D1. And you know that the voltage between the pins of D1 is 2 volts. So you can use 3.7 minus 2 to calculate the voltage across R1, so which is 1.7. Okay, and since this is a serial circuit, you know that the current flowing through R1 should be equal to that flowing through D1, which means 20 milliamp. Okay, so now since R1 is a resistor which follows Ohm's rule, we can then use 1.7 and divided it by 20 milliamp, and then we can know that the resistance shall be 85 ohms. Okay. If you didn't catch up with my calculations here, you can just like play back or pause and think a little bit about it. Okay, and I wanna also have my ohm symbol here, so I just like copied it from Google, and there we go. 85 ohms for this one, and see, after clicking this OK button, this R1 is being assigned with a value, which is 85 ohms. And it is the same for this D2 and R3 series circuit, but the only difference is that the output voltage here is a regulated 3.3 volts power supply from the MCU. So we can do the same calculation as well because we are using the same LED for both at D1 and D2. Their electronic characteristics shall be the same, so their correlations between forward current and forward voltage are also the same. So we use 3.3 minus 2, which is 1.3, and use it to divide it, and divided it by 20 milliamps, which means 65 ohms. All right. And then press OK, and here we are. All right. And for this R2 resistor selection, since it is being connected in serial with this potentiometer, and the potentiometer that I'm using actually ranges from 0 to 5 kilo ohms. So I will just type 5k ohm here to say like its value is ranging from 0 to 5k. I want these values to be a little bit closer. And then if we want to control the granularity of the analog readout a little bit better, we shall provide this R2 with a similar amount of resistance as the maximum of RV1, which is the potentiometer. So I would recommend you use kilo ohms resistors. For example, 1k ohm is definitely workable because like if it's using the maximum resistance it can have, it will still be like 5 kilo ohms, and the voltage being assigned to both sides of RV1 will be 3.3 divided by 1 plus 5 which means 6, then multiplied by 5, right? So I'm not gonna go too deep into these calculations. You can figure them out later. So I'm just gonna say like I select 1 kilo ohm as R2's value. 2 kilo, 5 kilo, both are fine. Like as long as it's reasonable, and you can easily adjust the analog readout from this potentiometer. All right, and then we click save, and if doing so after opening up this assign footprints window, you can see here that their values are being assigned. Okay, like R1 is 85 ohms, R2 is 1k ohms, and etc. And then if you go back to your PCB editor and update your PCB, there we go. You shall see that the Silkscreen printing here, as we can see, is showing up with the actual value of R3. All right. Yeah, that's a pretty good thing for us. But as you can also notice that, for example, this LED is being covered by this copper wire here. It happens, and I don't think it matters a lot. Like if we are encountering something like this, as long as it is readable for you, I think it's fine. Right? Like we're not having a really like super high standard for our PCB printing. I think as long as this makes sense and you can read it and sort it without any difficulties, it is good. All right. So here is the thing I want to introduce you the last, which is to go back to schematic layout and do the ERC check again. Okay, electronic rules checker. The reason why I want to do this is because I am adding a power supply or battery to this circuit right now. And I've also removed that PWR flag thing like I've created yesterday. And so you can see right now that there are pins not being connected, and there are also something say like pins of type bidirectional and power output are connected. Okay, but I think it might be okay. We can, of course, add cross to these pins here and press save. Then go to ERC checker. Okay, no error, but just a warning from the ground here. Okay, I don't know like exactly what is happening, but if I remove this PWR flag, let's see what will it get. Okay, it will still have an error. Okay, which is fine. This is definitely fine. So I'm just gonna move this to maybe to here, the battery, to say like this circuit is used for battery providing. And ERC again. Oh, okay, still one. So I assume that G and D shall be provided with the PWR flag as well, because it is a label being used here. Like we are not using VCC anymore, and since the battery here it is really here, there's no need to create a PWR flag for this like BAT labeled wire. So let me do this the last time, and we can see like the error is gone. And I think this warning is acceptable, so we'll just like keep it. Okay, I think that's all for my today's video, and in the follow-up videos, I will show you how to add a rechargeable battery to your schematic and how to connect that to your Arduino Cell MCU. And besides, I will also show you how to separate the sub-circuit of this layout into different units so you can better demonstrate that to others and it is also more readable to yourself. Besides those things, I will also try to create and optimize this layout a little bit better so there are not so many zigzag wires here. And if you are interested, I will also try the auto routing plugin that's designed for KiCAD. I might give it a shot. It might be super useful. All right, and that's all for today. Thanks for your watching. Stay tuned and bye-bye.